Okay, friends. Algebra, give them the lights for us, please. Thank you. So, questions on the front page. So, somebody said they had problems with the degree. So, like problem number 1. So, let me just kind of go through it. So, I have this, 6x second. Sorry. Just gotta squeeze 2 more in there. Oh. And 3x minus 2 minus 6x. Okay, so that's kind of the first one. So let me underline the ones that are in standard form first. That's in standard form. That's in standard form because it's decreasing. That's in standard form. And then this one, to put it in standard form, I need to take the sign preceding it and go from highest exponent to lowest exponent to constant. So that's standard form on that one. This one's not in standard form. Make sure you take the sign with it. So highest exponent to lowest exponent. This one is in standard form. This one is. This one's not. So we'll go. Make sure you take the sign with it that precedes it. Plus 11x, because I can combine like terms. I think that one to combine. Yep. Yeah, those are like terms right there and there. So I add those together. This is in standard form, and then this one needs to be put in standard form. So again, highest exponent, combine any like terms, so negative 3x plus 2. Okay, so now they're all in standard form. The leading coefficient is, once you find your highest exponent, it's the base number, the number that's right next to it, not the number that it's raised to. So the leading coefficient. So leading coefficient we'll have in black. Okay. There you go. So this already is the leading coefficient. This is the leading coefficient. This is the leading coefficient. This is -1, basically, as the leading coefficient. Or actually, I take that back. Let me undo that one. Oh, come on. I didn't do them that far. This is actually the leading coefficient right there. If there's nothing there, it's got to be 1, right? So x and 1x are the same thing. This is my leading coefficient. This is my leading coefficient. This is already has its leading coefficient, which is a 1 out front. And then this one has that is the leading coefficient, and this is my leading coefficient, and this is my leading coefficient. So you look for your highest exponent, whatever the base number and the sign preceding it would be. And then it says name by degree. Okay? So this is basically x to the 0 power. Okay, x to the 0 is the same thing as 1. So this is if we name it by degree, how do I name it? It's a constant. I believe this top one's a constant. This one is linear. This one's quadratic. Because I have squared, this one's also quadratic. This one is cubic. So I'll write CU for cubic because it's raised to the third. This one is a quadratic. This one is a cubic because it's raised to the third, so I'll put CU again, not for copper. This is a constant, it's just a number, and then this is a quadratic. Okay, so if it's raised to if you just have a number by itself, it's a constant. If you have a number with an x next to it, and x is not raised to any exponent that's listed, but so it's x to the first, that's linear. If it's raised to the second, it's quadratic. If it's raised to the third, it's cubic. Okay? And then name by the number of terms. All right, we'll do that in green. Name by the number of terms. That's a monomial. I'll just abbreviate it. There's two terms there. That's a binomial. That's a monomial. There's one term. There's three terms, so it's a trinomial. And I'm just abbreviating it. And if you abbreviate on a test, guess what? I totally know what you mean. That's a binomial because there's two terms. There's three terms there, so that's a trinomial. And then after I have put the terms back together, I got 1, 2, 3, so that one would be a trinomial. That's a monomial. And then again, three terms, 1, 2, 3, so that's a trinomial.
Wait, what did you get for 6x part?
What number is it?
6x, it's 8.
Number 8. I called it a trinomial, and the reason I did is once I combined like terms, I had 6x and 5x, so it makes it 11x. So once you combine your like terms, then there's only three terms, so it's a trinomial.
Oh, and also on the number of terms, if it's 4 or more,
just call it a polynomial.
but isn't it called something else?
No, just polynomial is fine.
Okay.
Monomial, binomial, trinomial, polynomial.
Because like someone corrected me on it, I was like, my notes say it's poly.
I'd say poly. I'd stick with poly.
Okay.
Being I'm grading your thing, if you put poly, you nailed it. All right, questions on 11, 12, 13, or 14? 11, 12, 13, or 14? We're good? Feel all right? All right. Flip the page. Questions on any of those?
18.
18? Okay. They just want us to find the perimeter on it. So this is number 18. So we have a rectangle of some sort. So, x plus 6 is the top, and x plus 3 is the side. So we want to find the perimeter of it. So we have to realize this is also x plus 3 because rectangles have equal sides, and then top and bottom are both x plus 6. So to find the perimeter, I need to add them all up. So I go x plus x plus x plus x. Well, that's 4 x's. And then that's 9, and 9, that's 18. So my perimeter is 4x plus 18. Anything else on that? Will you make sure your name is on top of that? And pass it forward, please. And I will make sure I put that in the grade book for you. Thank you. Thank you. Thank you. What are you doing? Sharing earwax, it looks like. Oh, quiet in here, man. You guys all right?
No.
I'm giving you a hard time. All right, so just a couple of things. Just a couple of things. Here you go. Thank you. Yep. So just so for those of you who are writing stuff down in your book, let's see. We had our stats quiz that's already done and graded. Some of you still have to do it, so come, make sure you come see me. We have a 3-day weekend. We don't have school on Monday. And then that means that next week's only a 4-day school week. And then we don't have like a major quiz until February 6th. I mean, that's kind of far out, right? But we'll have little small quizzes that go along with our units, like 1 or 2 questions, half sheet of paper type of thing. So just so you know that, okay? Cool.
Don't worry, I won't make Brad take those earbuds out. They look rude.
Huh?
Not even listening.
I know, but please take them out. I know. Keep the earwax in. Okay. Everybody has a note page. So let's just talk for a few moments about, you know, it's hard. You all know that when there are things that we do in math that you look at going, when do I really ever use this in life? And there's, you know, quite often we don't necessarily walk around going, dude, we're going to add polynomials together. You know, that's just not every day. Agree? I mean, even me as a math teacher, once I'm done teaching, I'm not driving down the road going, oh, look, that's x to the third plus 2x plus 7, and that's... Yeah,
Elon Musk says we shouldn't go to school.
Well, you know, he obviously was formally educated and did quite well and went to an Ivy League school. And so him saying we shouldn't be educated is basically us. That's
No, he
basically...
said nothing's really important except for college.
Yeah, but
You have to get
how do you get the
somehow.
foundation of college if you don't have...
Kindergarten.
So you gotta learn your career first.
So that's great, and you know it's kind of fun when a billionaire is saying that, but I hate to tell you, not everybody's going to be a billionaire in life.
Yeah, I am.
Well, you might be, but not everyone will. So when I just want to like go over some times when you would come across polynomials being added together and you don't realize it. I know some of you in here are musicians. Agreed?
Sure.
So let me ask you this.
I have my rap song I always have class.
Jacob, what instrument do you play?
The alto sax.
Okay. So with your alto sax, is it possible that you play the wrong note that other people who have your same instrument play? So it's possible. And can usually I would imagine Mr. Libby could hear if somebody is off, right? But why does he hear? Why would somebody hear somebody being off? What's really taking much? Yeah.
It just doesn't sound connected.
Right, it does. Thank you. That is a beautiful, beautiful answer. It's not connected. So what you have to think about, anytime you make some sort of sound, whether it's through an instrument, through your voice, through your butt, snorting, popping your ears that goes in your ears. I don't know if that's ever happened to you guys, but anytime I have clogged ears and you yawn and they open up, it's like, you get this weird noise. There's some sort of sound wave that comes off of it. There are some sound waves, if you were to look at the sound wave, you'd say, wow, that's really nice looking. And a really nice looking sound wave also sounds pleasant to our ears. Does that make sense? So if you look at this sound wave that's doing this nice, doing this, just a nice wave motion. If you hear it, you're like, hey, that's kind of cool. Now, if everyone's playing the same note, that's the same sound wave that we're hearing, and the more of them that happen, more instruments that are playing that same note, the more it's resonating around you, which really sounds quite pleasant. But let's say you had 100 of your saxophones, and there's 100 people playing them. You personally don't have 100, but there's 100 people playing your exact same instrument, and they're all on the same tune. If you all just say, we're going to hold this note, and you start, you could hear, you might not be able to identify, but if you had 100 people, like if you were in the center of a circle, and there was a circle of those saxophones all the way around you, okay, and they're all playing the same note except for one of them, you actually hear that incorrect note. Okay? Isn't that kind of weird? And it becomes one of those, wait, somebody's off, wait, no, you should be playing D, not B or whatever.
Jacob?
So, but how it works mathematically is because all sounds are a wave. If you're playing the same wave over and over and over again, basically you're just tracing on top of that same wave, so I'm making it darker and darker and darker, so it becomes more resilient for you to hear. If the one person's playing a different note, it's a different wave, so it's then coming to your ears at a faster or slower pitch because sound travel, certain notes travel, or all notes travel at a different wavelength. It comes to your ears quicker. So if you talk about a piano where you have 88 keys, if you play something to the far right, that's a really high note. If I play a C here and I play a C down at this end, it's going to look, so the C down at this end is going to be a really long, drawn out wave. And the C at this note is like this. But you can see how it matches up. So you're like, oh, I can tell it's the same note I'm playing, C and C. Now, why do some notes that you play together sound really good and some don't? That's called a chord. If for those of you that aren't musically inclined, you can play multiple notes at once, and there are some chords that are very pleasant to listen to, and then there are some you're like, ah, okay? And you don't have to be a musician to know that some sounds sound great and some sounds don't. Okay? Does that make sense?
Yeah.
Okay. So let's just do this. Let's just see if I have Wi-Fi. Cool. Siri, play me the note of middle C. I don't know why it's playing Cool the Engines by Boston. All right.
Play More Than a Feeling by Boston.
Siri, play me middle C. Yeah, baby. Well, if you just listen to that, you have a guitar playing with drums and a bass going right now, right? And you have a second guitar in there. Can you hear the second guitar playing? Does it sound okay? I mean, you don't have to like the song. So, are there other sounds that wouldn't sound good? Absolutely. Okay. Can anybody whistle real loud? I'm talking like that.
Oh, you can.
Can you? Well, I need a second person to be able to do it. Nope. Can anyone?
No.
You sound like a bird.
My dad doesn't get me.
Wait, how do you do that?
I can also do this. Ready? Oh yeah, how cool is that one? So if there was a second person, if we had a second person who could whistle like that real loud, we could hold it, you would actually start hearing something weird in your ear. It'd start going, woo! You'd hear the noise, but you'd hear woo, woo in your ear. And it's actually a destructive interference between the sound waves. Okay? So one wave is up and one wave is down. If you add the two together, they cancel each other out. Okay? Yeah. So it gets this note going up, and then it gets to a certain point, and this note going down, it comes to a certain point. They're equal from basically the x-axis, if we wanted to say that. So you have a wave coming above it and going below it, and then you have a wave that's a little bit different. So destructive interference is something that you can actually hear quite a bit with. So this is just kind of, I just want to give you kind of an idea of where this mathematical principle is applying outside in the real world. And most of you have earbuds that I've seen. So I would imagine some sort of music you're listening to. Why do you listen to the music you have? Maybe you just like the lyrics. Maybe you just like what the music the song itself is. Maybe you like the instrumentals. I don't know. Or maybe a combination of all. So let's move down and start talking about adding polynomials. Okay. So does everyone agree I have two polynomials that happen to be grouped together? Okay. What does that mean when I said grouped?
Together.
They're in parentheses, right? So really right now, everything here, if I have a plus sign, I can drop all of my parentheses if that was a plus sign right there.
Are we going to use PEMDAS, Mr. Stirrup?
Well, not yet, but eventually. All right, so let me ask you this. What does the highest exponent appear to be up there? X to the third? Does everyone feel comfortable with that?
Sure.
So I'm going to list that first because I'm going to put it in descending order and I'm going to combine like terms. I have x squared. I have 3x squared here. Do I have any other x squareds up there?
Yeah,
Six.
6x
Six.
squared.
So
Yes.
how many x
Yes.
squareds do I have then?
3.
9. I have 3 of these and I have 6 of those. So I have a total of 9x squareds. Is that okay? Is that cool? And then I have my x's. How many? I got 16 of those x's. And then do I have anything left I should write down?
Negative 15.
Yeah, negative 15 is my constant. So now I have just combined my like terms together. And I have x to the third plus 9x squared plus 16. Ooh, I forgot the x right here. I apologize. Minus 15. So graphically, if I were to graph this as y equals, this graph would kind of look something like this. That's kind of a nice looking graph, isn't it? It's like, ooh, smooth transition. Cool? You don't have to know what the graph looks like. I just wanted to kind of put it there saying, hey, there is some sort of balance to mathematics. Can I move off this screen?
Yes.
So number 3, I don't have the left side grouped, the right side grouped, and preceding these parentheses is an addition sign. So I can go ahead and drop my parentheses, and none of the signs change. Is that okay? Now I have some like terms. What is my highest exponent up there?
4.
It's 4. Okay. Do I have any others? No. I'm just going to list that. So that's 4x to the 4th. Feel good about that?
Sure.
And then do I have any to the third?
8x to the third.
Oh, yeah, right here. So that's positive 8x to the third. So bring that down. I like that. And then I have x squared. So that's an x squared and that's an x squared. So how many of those do I have? Count them up.
4.
9 and 12 is?
21.
21. So I get 21x squared. And then I have my x and my x. So negative 3 and negative 4 combine together to give me negative 7x. And then I have my numbers last. 6 minus 5 is 1. Okay? So it goes from the 4th to the 3rd to the 2nd to the 1st degree to the constant. That's standard form. If I had graphed this, this is what this graph would look like. Okay, arrows meaning it's going to keep going. Okay, so there is some sort of rhythmic pattern that is taking place, which is cool. Can I move on? Again, you don't have to know what the graph looks like. You just need to know how to combine like terms, drop the parentheses. All right, so we had where we were just adding them together. But now we're going to get into the subtracting. Notice this. Let me just we'll highlight this, and we'll make sure we highlight over there, and we'll highlight over here, and we'll highlight right here. A point I'm trying to make to you, I need you to pay attention to your signs when we're subtracting polynomials from each other. Okay? So I kind of underlined it a little dramatically. Okay. So, do I have anything right out in front of this? So I'm going to go ahead and drop the parentheses, and all of my signs stay the same on this one. Is that all right so far? But here's the big kicker. I have this subtraction sign, so I have to distribute a negative here, here, and here. And if I distribute a negative, it changes all of those signs. So this becomes negative 2x to the third minus 3x minus 9. You see how those...
Right side.
Yeah. So if you have a polynomial, immediately to the left of it, if it's grouped, if it's negative, make sure you distribute over that parentheses. I didn't have anything over here I needed to worry about distributing over.
Unless you had a negative before.
Good. And I don't, right?
Yo,
All right, so what's my highest exponent there?
probably like
The third.
2x.
So I have this and I have this. So if I combine negative 2 and negative 2, I get negative 4x to the third. And then I have my x's. That gives me negative 2x. And then I have my those, which gives me negative 5. this graph actually looks like this, which is backwards than from the one that I showed you just a couple minutes ago. Okay, it actually flips over. What flips it over is this negative, actually. But don't worry, you don't have to worry about what it graphs to. I just want you to know there is some rhyme and reason to these. Can I move on? Feeling okay about this? Okay. Let's see. So my very first of grouped, is there any negative sign out here?
No.
No. So I'm just going to go ahead and drop those parentheses, keeping all the signs the exact same here. But I do indeed have a negative here, so I have to make sure it comes here, 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 and here. And it's going to change every one of those signs. Okay? So it changes the negative 7x to the third to positive 7x to the third. It changes the negative 2x squared to the positive 2x squared. It changes the positive 2 to negative 2x. And it changes the negative 5 to positive 5. You feel comfortable with that?
Mm-hmm.
So all those signs changed because I had to distribute over to the right the negative. Then we're going to combine like terms. So it looks like x to the third is my highest exponent. So if I add 5 and 7 together, I get 12x to the third. Is that okay? And then I'm going to combine the x squareds. What happens to the x squareds? They cancel each other out, right? So I don't have an x squared term up there. So I have a negative 2x squared and a positive 2x squared. If I add them together, I get 0x squared. And 0 times anything is 0, right? So they cancel each other out. And then I'm going to go to my x terms. So negative 6 and negative 2 combined together to give me negative 8x. And then my last one is positive 6, positive 5. So I get positive 11. And that's my answer. And this one actually looks like this. 1, 2, 3, 4 is the time. So again, that function kind of looks like that. We doing okay on notes? Doing okay on time?
Yes.
Can I move on? All right. So don't forget to change signs if multiplied by a negative, okay? Or distribute the minus sign if you needed to. Is that okay to say something like that? Again, if that negative sign precedes a grouping, a bunch of parentheses, you distribute the negative sign to everything and it changes all the signs to opposite of what they had been. We okay so far? May I move on? All right, so that's going to be your homework, but there's a couple of questions here they wanted us to do. So let's just make sure we can do these. 2x plus 7 and x minus 2. We're finding the perimeter. We're adding up all the x's. So I get 3x and 3x at 6x. And then 5 and 5, positive 10. So the perimeter of this shape is that. If I wanted to find the perimeter of this shape, notice I have a 4x squared and x squared, so I get 5x squared. So that's my perimeter so far. And then I have a negative 2x and a positive 4x, so that's plus 2x. And then I have a negative 8, negative 2, that's negative 10. Negative 10 and positive 6 is negative 4. So this actually has a perimeter of that. Okay. All right so far? And I'll come back to this page in a minute. 17, 18. So this is actually page 17 and 18 in your workbook. Okay, I think some of these might follow along some of your things. So the perimeter of this triangle happens to be this. So if I add all three of my sides up, I get this. But I don't know what this third side is right now. So let's see if we can figure this out. So my perimeter is 7y minus 12. So I know that 2y plus 4 plus 4y minus 6 plus question mark. That question mark is actually this green side. Okay? So let's see if we can start figuring this out. combine like terms over here, 6y minus 2, and then I still have this question mark. So I want to get that question mark all alone. So what do you think I should do with 6y?
Cancel.
How? Subtract it. What should I do with negative 2? Add it. Okay? So I'm going to do that to both sides. I'm going to subtract 6y from both sides. And then I'm going to add 2 to both sides. And that's going to allow me to know that those cancel that. So that gives me question mark is equal to y minus 10. So that means this side right here is y minus 10. So we'll find our third side.
Wait, why did you add the 2 on that side? When you could have added the 12 to the 2.
Oh, because I wanted to get the question mark all by itself. So I wanted, if I move it over, I have to add it. And I just used question mark, but you could use any verb. You could have a smiley face if you wanted to, or whatever. Was that all on the notes, or was there any more?
There's another one.
There's one more?
Uh,
Can I move on?
Yeah.
All right. Given the rectangle, this rectangle has a perimeter of that. Okay, so they tell us we have a perimeter of this for this whole rectangle. Okay, we know that this side and this side are both 3x minus 8. So I have question mark and question mark. So how many question marks are up there?
2.
2. Everyone agree with that? Okay, so this means that if I were to take 14x minus 2, or minus 12, excuse me, is equal to 3x plus 3x, that's 6x. Negative 8 and negative 8 is negative 16. And then plus 2 of these question marks. Okay? 2 of the question marks. Does that seem okay so far? All right, so I want to try and get the question mark all by itself. So things that I might be able to approach on this, I might be able to subtract 6x here and 6x here. That's starting, so that cancels. And I could add 16 here and 16 here, and that cancels. And that still leaves me 2 question marks. And if I combine that, it looks like an 8x, and that's a plus 4. How do you think I can get question mark all by itself? Divide it by 2, right? I have 2 question marks, so if I divide by 2, if I divide 8x and 4 by 2, I'm going to find that I have this being 4x plus 2, and this would be 4x plus 2. If I add 4x plus 2 and 4x plus 2, I get 8x plus 4, so I get the top and bottom. So what's my longer side?
4x plus 2.
That's it. Is that it?
One more.
One more? Okay. You know what? Let us hold off on this. We're going to hold off on doing this because this is coming up, okay? There was nothing more beyond that. Okay, cool. So, that's going to be your assignment that will be due tomorrow, front and back. Cool? We good? Everyone happy? Love it. Yes. Let me hit stop right here.